Alright, so you'll be asked on the Regents exam to rationalize a denominator. So that means if you have a irrational denominator, such as some sort of simplified radical that can't be simplified further, you don't want to have that down there. So one way to deal with that is to rationalize it. And you do that by multiplying it by itself. Now, if you multiply a radical by itself, it comes out of the radical, right? Because that's the definition of a square root in this case. Actually, if this was a cubic root, we'd actually have to multiply by itself so that we had 3 of it. But because it's a square root, we only need 2 of them. So that'll become 3a squared 3a squared times b. Now, we're not just allowed to randomly multiply a denominator by that amount. Whatever we do to the denominator, we must do to the numerator, so that multiplies by 3a squared times b as well. And that will become 3 radical 3a squared b. Alright, and you must do this because this is equivalent to 1, and you are allowed to multiply any fraction by 1. Alright, so this would be the same expression with a rationalized denominator. Alright, so let's take a look at 2 more examples. This one's a bit more unusual. You might notice that we have a radical here, and we have a non-radical here. Now, we can't just multiply by radical x, because if we do that, we'll get radical x over here, and then we haven't done anything useful. Alright, so you might think we could multiply this by itself to simplify. And that'll give us x squared minus 2 radical x. If you work this expansion out yourself, you'll see why. Minus x, and then we still have a radical in our denominator, which again is the whole point of rationalizing a denominator. But the part to notice that's interesting is this middle term is where that goes. And this is how we came to deal with that, how we'll deal with that. So to cancel out that middle term, we're actually going to use what's called the conjugate. Alright, so a conjugate I can't spell conjugate. I don't remember, honestly, how to spell it. Conjugate? This is a bit of a guess at the spelling, but that means if you have a binomial, its conjugate would be the opposite operation. So we have a plus b here, and a minus b would be its conjugate. Now when you multiply that out, you're going to get a squared minus b squared. We don't get a middle term, and that's because those cancel out. In case you forgot, let's look at that again. Properly worked out, this is a squared minus ab plus ab minus b squared. So these middle terms are opposite, so they cancel out. So we'll get something similar here when we multiply with a conjugate, but that middle term that became a radical will cancel out, which is what we want. So let's work that out, and we'll get x times x is x squared. X times radical x is positive x radical x. Then we'll have negative radical x times x, which is negative x radical x. And negative radical x times radical x, which is negative x. And now these are like terms, so they will cancel out. So rather than write them out, we can just try and remember that this is a difference of squares and utilize that to unfactor. Since this is a difference of squares, that means this squared minus this squared would be its product, because its factors are the sum and difference of the square roots of these values. Alright, now just like before, whatever we do to the denominator, we must do to the numerator. We won't have a radical in our denominator, but we will have made our numerator a bit more complex. So that's x squared plus x radical x. Okay. Now let's look at one more example. In this case, we have a binomial again in the denominator, but in this case both terms are in the radical. So by simply multiplying it by itself, it will come out of the radical. So that's x plus 2, which is all we really cared about. So we'll put that up here. And this will be equal to 2x plus 4 times radical x plus 2. And that's as simplified as it's going to get up top, so I guess that covers it. So the key thing to remember here would be to get rid of a binomial irrational denominator, you should multiply by the conjugate. Alright, so if we had a denominator of 7x minus radical 3 plus 6, the conjugate would actually be 7x plus radical 3 plus 6. Okay, so the radicals will be opposite signs, but same terms for the conjugate.